All right, let's look at this example. Integration of sine 4x multiplied by sine 8x. Now in integration, whenever we know there is multiplication of either sine or cos terms, we use de-factorization formulas as we discussed in the previous video. We also know for sine and sine, the de-factorization formula is if it is sine A into sine B. The de-factorization formula is minus half cos minus cos. Okay, sine and sine is the only formula where there is minus half. All the other combinations of sine and cos, there is plus half. It starts with plus half, but just the sine and sine, the combination starts with minus half. Okay, the formula is minus half cos minus cos, and the angles are a plus b and a minus b. Okay, we will apply that formula here in this integral. Okay, also in this, I like to always keep my angles in the descending order. That just makes my calculation little bit easier. Okay, so the before applying that formula, I actually write that angle in descending. So I write 8x first and then I write 4x. So my integral will become sine 8x into sine 4x dx. All right. Now let's apply this formula. So integral of formula starts with minus half cos minus cos. So that will become cos minus cos. All right. The angles are A plus B and A minus B. So 8x plus 4x will go here. 8x plus 4x is 12x. And here 8x minus 4x because it's a minus b. 8x minus 4x is 4x. That's how it will turn out. Take that minus half, which is constant, out of the integration. So you are left with integration of cos 12x minus cos 4x. Also, don't forget that with respect to x, dx. Minus 1 by 2, put a bracket. We know integration of cos x is sin x, but since this is cos 12x, the integration is sin 12x divided by 12. We always divide by the coefficient of x. Okay, minus integration of cos 4x is sin 4x divided by 4. Close the bracket, add the constant of integration, and that's your final result. Okay. All right. It's also important to write this formula in exam. Just write we know that sin A into sin B is this formula, and then you just apply this result. And that's your final answer. All right, let's look at next example. This is very important for your class 12 board exams. It says integration of 1 minus cos x divided by 1 plus cos x. Now, whenever in integration, there is 1 minus cos and 1 plus cos. There is a standard formula that we use, whether it is 1 minus cos 2 theta or 1 plus cos 2 theta. There is a standard formula in both the situations that we like to use. If it is 1 minus cos, the formula is, both the formula starts with 2. Okay. If it is 1 minus cos, the formula is 2 sine square. And if it is 1 plus cos, the formula is 2 cos square. Now the angle is very important. The angle becomes half in both the cases. If it is 2 theta, the angle will become half. Okay. So if it's 2 theta, it will become theta. 2 theta, the angle will become theta. Whatever the angle is becoming half in this formula. Okay. I hope that makes sense. All right. Let's apply that formula here. So you get integration of 1 minus cos. Now 1 minus cos, both the formula, whether 1 minus cos or 1 plus cos, both the formula starts with 2. Okay, so 1 minus cos is 2 sine square, 2 sine square. That angle is very important, it becomes half. So in this case also, the x will become x by 2 divided by 1 plus cos. 1 plus cos. The formula is 2 cos square. The angle becomes half x by 2. with respect to x. Now that will become integration of, so I equals integration of sine square x by 2 divided by cos square x by 2 is tan square x by 2 dx. Okay, so sine divided by cos is tan. So that will become tan square x by 2. Now in integration, we don't have direct formula for tan square theta. Integration of tan square theta, we don't know. But we know integration of sec square theta. We do know integration of sec square theta d theta is tan theta. Why is integration of sec square theta tan theta? Because we know the derivative of tan theta is sec square theta, which is why the integration of sec square theta we know is tan theta. Now, if we don't know the integration of tan square, but we know the integration of sec square theta, it is best to convert that tan square theta into sec square theta. How you will convert it? You will use trigonometric identities. Yes, that's right. We know that 1 plus tan square theta is sec square theta. So therefore, that tan square theta, here can be written as sec square theta minus 1. So therefore, that integral can be written as sec square x by 2 minus 1. So basically, we convert that tan square into sec square using trigonometric identity. Why do we do that? Because we do know the integration of sec square theta, but we don't directly know the integration of tan square theta. Okay. So now give the integration to both the terms. You get integration of sec square x by 2 dx minus integration of 1 dx. Now the integration of sec square x by 2 is tan x by 2. However, don't forget to divide by coefficient of x. Coefficient of x is half. So you have to divide by coefficient of x. Always when you are done integrating, check the coefficient of x. If coefficient of x is not 1, divide by that coefficient of x. In this case, the coefficient of x is half. Divide by that half. Okay, minus integration of 1 is x plus c. Okay, now that half, this 2 is in denominator's denominator. It can go into numerator. Okay, so that will become 2 because it's denominator's denominator. Denominator's denominator is always numerator. So that goes into numerator. So that will become 2 tan x by 2 minus x plus c. Okay, that's your integration I. And that's your final result that we are looking for. All right, let's look at this next example. Integration of cos x divided by 1 plus cos x. Again, a very, very important one for your exams. Whenever you see, we have learned, whenever you see this 1 plus cos x or 1 minus cos x, there is only one formula that we use. For 1 plus cos x, if it is 1 plus cos 2 theta, the formula is 2 cos square theta that we just saw. Okay, 1 plus cos 2 theta is 2 cos square theta. That angle becomes half. Okay, so let's first apply that formula here and then we'll look at what to do with the numerator. But let's first say this is integration of I. Let's first do the denominator. So 1 plus cos x is 2 cos square, 2 cos square. That angle becomes half because it's 2 theta, it was theta. So here that x will become x by 2. Okay, now the important part is denominator. What to do with this cos x? Now, since you are converting the denominator angle into x by 2, it is best idea for simplification to convert that numerator's angle also to x by 2. So it is best to convert that x into x by 2. And how would you do that? We know for cos 2 theta there is a formula. Since it is cos, we know for cos 2 theta, we saw it in the previous video where we did all the formula development. The formula for cos 2 theta, there are four formula. Let me remind you. So first formula was cos square theta minus sine square theta. The second formula was 2 cos square theta minus 1. The third formula, yes, it was 1 minus 2 sine square theta. And the fourth formula was 1 minus tan square theta upon 1 plus tan square theta. For cos 2 theta, there were four formulas that we learned in our previous video where we did the formula development. In this case, we will apply this first formula. Even if you apply second or third formula, I think that will work. But let's apply the first formula. Okay, it's cos square theta minus sine square theta. Remember that angle is becoming half. If it is 2 theta, it is becoming theta. So in this case, this is just like cos 2 theta. Okay, so we can apply this formula, but this angle will become half. So it will become cos square theta, so angle half. So if it is x, it will become x by 2 minus sine square x by 2. All right, I hope that makes sense. Now it is very easy because all the angles are now x by 2. What you can do is you can just simply split this term split this denominator into both the terms. Okay, so we just split. So we get integration of cos square x by 2 divided by 2 cos square x by 2 dx. Actually, let's just first split minus integration of, minus sine square x by 2 divided by 2 cos square x by 2. And let's just close the bracket and write dx. Okay, so we just split that term in denominator into both the terms. All right, uh, now that cos square x by 2 and cos square x by 2 will get cancelled. That will just leave you with half in the first term. Minus, in the second term also you have half sine square x by 2 divided by cos square x by 2 is tan square x by 2 dx. All right, I hope that makes sense. Now that half and half you can take common, half and half you can take common and take it out of the integration. That half and half is common and just take it out of the integration and you are left with 1 minus tan square x by 2 dx. All right, I hope that makes sense so far. Now we know the identity is for 1 plus tan square theta. We know that 1 plus tan square theta is sec square theta, but there is no identity for 1 minus tan square theta. Okay, so basically what we can do is we can just substitute the value of tan square theta from here. We know tan square theta is sec square theta minus 1. So just substitute that value. So half integration of 1 minus, put a bracket. After minus, always put a bracket. Okay. So that tan square theta can be written, or tan square x by 2 can be written as sec square x by 2 minus 1. Okay. Close this bracket. So this bracket closes outside here and dx. Now half integration of 1 minus, now put that minus inside the bracket. So you get minus sec square x by 2 and that minus and minus will become plus 1 with respect to x. Okay, I hope that makes sense so far. Now that 1 plus 1 will become 2. So half integration of 2 minus sec square x by 2 with respect to x. Okay, now it's very simple. Just split the integration in both the terms. So you are left with half, open bracket, integration of 2 dx minus, give the integration to sec squared x by 2, sec square x by 2 dx. All right, half, open the bracket. Now the integration of 2 is nothing but 2x, because that 2 can be taken out of integration and you will be left with 1. So integration of 1 is x, minus integration of sec square theta or sec square x is tan theta. So in this case, the integration of sec square x by 2 is tan x by 2. However, you always have to divide by coefficient of x. The coefficient of x is half. So you always have to divide by half, close this bracket, add the constant of integration c. Okay. Now we'll just simplify this a little bit. So we get half 2x minus, now that half or this 2, it's in denominator's denominator. The denominator's denominator can go in numerator. So that is 2. So this 2 can be go in numerator. Tan x by 2 plus c. Now this 2 and this 2 can be taken common from these two terms, and it can come out here. So that will become 2 divided by 2. So this 2 is this 2 and this 2, when you take common, it will come out here. And this 2 is already present. And you will be left with x minus tan x by 2 plus c. That 2 and 2 will get cancelled. And that's your result of integration. Okay, that is our final answer. I hope that is making sense so far. All right, let's look at this example, integration of sine to the power 4x. Now, whenever you see in integration, the powers of sine or cosine, we always try to convert that power into power 1 because we cannot integrate power 4 because there is no chain rule as such in integration. Like we have in derivatives, there is no chain rule in integration. So we cannot directly integrate sine to the power 4. We will have to convert that power 4 into power 1. But there is no such direct formula for converting power 4 into power 1. But we do have a formula for converting power 2 to power 1. We know sine square theta is 1 minus cos 2 theta divided by 2. Also for reference purposes, which is our next example, we also know cos square theta is 1 plus cos 2 theta divided by 2. If you see this carefully, this is the exact same formula that we also did in our previous example. In the previous example, if you see the formula that we did was 1 minus or 1 plus cos 2 theta is 2 cos square theta. So if you just take that 2 in the denominator, you get this formula. If you take that 2 in the denominator, you get the formula for cos square theta. Okay, similarly for sine square theta, we have this formula. This formula basically converts your power 2 into power 1, whether it is sine square or cos square. For sine square it is minus, for cos square it is plus, but it converts your power 2 into power 1 in both the cases. But remember that angle is double on the right hand side, okay? That angle becomes double, okay? So let's apply that formula here. But wait, this is sine to the power 4. Now that sine to the power 4, we can write it as sine square x the whole squared using the laws of indices first. Okay, before applying that formula for sine square, we have to convert that sine to the power 4 as sine square to the power 2. All right, now let's apply that formula. So we get for the sine square x, for sine square theta, the formula is 1 minus cos 2x divided by 2. The angle becomes double dx. Don't forget that there is a whole square here, okay? All right, I hope that makes sense. Now just apply that square in the numerator and in the denominator. So you get integration of 1 minus cos 2x the whole square divided by 2 square, which is 4 dx. Now that 4 is constant can be taken out of the integration. So you get 1 by 4 integration of 1 minus cos 2x the whole squared dx. Now we can apply the formula a minus b the whole squared here. So that will become 1 by 4 integration of a minus b the whole square is a square, 1 square 1 minus 2ab, so 2 cos 2x plus b square, so cos square 2x and dx. Just apply that formula a minus b the whole square, a square minus 2ab plus b square. Okay. Now, if you notice again, there is again the cos square term. Now, if there is a cos square term again, we can convert that power 2 into power 1 by using this formula again. Okay, so before integrating, we'll also have to take care of that. So we get 1 by 4 equals integration of 1 minus 2 cos 2x plus cos square 2x. We can convert that using this formula. So I get 1 plus cos 1 plus cos, the angle becomes double. So that 2x will become 4x and divide by 2 dx. All right. I hope that makes sense so far. Now, in order to simplify, you can either give the integral to all the terms, or actually I'll prefer to multiply this 2 or cross multiply this 2 with those terms. So you'll see what I mean by that. So 1 by 4 integration of. So multiply this 2 with 1. So 2 times 1 is 2 minus. Multiply this 2 over here. 2 times 2 cos x is 4 cos 2x plus this term which is present. So 1 plus cos 4x and the whole divided by 2 dx. Okay, it's just like taking LCM. Okay, so make the denominator common. Okay, so then this 2 and 4 will become 8 outside of integration. So 1 by 8, open the bracket, integration of, you're left with 2 minus 4 cos 2x plus 1 plus cos 4x with respect to x, and close the bracket. Now that 2 plus 1 is 3. Okay, so that will become 1 by 8 integration of 3 minus 4 cos 2x plus cos 4x dx. Okay, now it's very simple. You just have to split the integration in all the terms. So 1 by 8, open the bracket, give the integration to all the terms. So you get integration of 3 dx minus integration of 4 cos 2x dx plus integration of cos 4x dx. Okay, now 1 by 8. So this 3 can again be taken out of integration and you will be left with 1, and integration of 1 is x, minus the 4 can be taken out of integration. You will be left with cos 2x. The integration of cos 2x is sine 2x, but we have to divide by coefficient of x. Always remember to divide after integrating. Always remember to divide by coefficient of x, plus cos 4x. Again, the integration is sine 4x divided by coefficient of x, which is 4, plus add constant of integration c, and that's your final result. All right, another very similar example, integration of cos to the power 4 2x. So very similar to the previous example that we did. We did sine to the power 4x. Now this is cos to the power 4. Remember, this is 2x. Okay, be careful with that. Be very careful with those angles always. So we know the formula for that we just saw. Cos square theta is 1 plus cos 2 theta divided by 2. Okay, so now we can apply that formula. Also remember, for sine square theta, it was 1 minus cos 2 theta divided by 2. Those angles become double on the right hand side. Okay, let's apply those formulas. Before applying that formula, let's say this is integration I. Okay, so that I integration will become, before applying that formula for cos square, we have to convert this power 4 into power 2 by doing like this: cos square 2x to the power 2 dx. Okay, we just use laws of indices here to convert that power 4 into power 2. After that, we can apply that formula for cos square theta. So that will become 1 plus cos, 1 plus cos, that angle becomes double. So if it's 2x here, it will become 4x divided by 2, the whole squared. All right, I hope that makes sense. Very similar example that we did in the previous one. Very similar to previous one. Okay, now that whole squared can be given again to numerator and denominator. So that will become integration of 1 plus cos 4x the whole squared divided by 2 square, which is 4, with respect to x. Okay, so far so good. That 4 is constant can be taken out of integration. So that will become 1 by 4 integration of 1 plus cos 4x the whole squared with respect to x. Okay, now 1 by 4 integration of. Now we can apply the formula a plus b the whole squared. A plus b the whole squared is a square plus 2ab. So 2, 1 into cos 4x, which is cos 4x, plus b square, which is cos square 4x dx. Just apply that formula a plus b the whole square, a square plus 2ab plus b square. Okay. Now again it is cos squared 4x. Again it is power 2 in cos. So again we'll have to use that same formula that we used, which was 1 plus cos divided by 2. Okay. So again we'll have to convert that power 2 into power 1. So that will become 1 by 4 integration of 1 plus 2 cos 4x plus cos square 4x is 1 plus cos 8x divided by 2 dx. Okay, we apply that formula for cos square theta. 1 plus cos 2 theta divided by 2. That angle becomes double here. Okay, now in order to simplify this, 1 by 4 integration, we can again take cross multiplication or LCM. So we can make the denominator common 2. Okay, so multiply this 2 now here. So 2 times 1 is 2 plus 2 times 2 here is 4 cos 4x plus 1 plus cos 8x with respect to x. Okay, now that 2 and 4 can become 8 outside of integration, because 2 is constant, can be taken out of integration. So 1 over 8 integration of. Now finally you are left with also this 2 and plus 1 is 3 plus 4 cos 4x plus cos 8x with respect to x. Okay, now you will get 1 by 8. Give that integration to all the three terms now, and also put a bracket. Integration of 3 dx plus integration of 4 cos 4x dx plus integration of cos 8x dx. Close the bracket. Okay, now very simple to integrate, all standard formulas. So 1 by 8, open the bracket. Integration of 3 is 3x plus that 4 is constant, can be taken out. Integration of cos 4x is sine 4x, divide by 4, because we always divide by coefficient of x. Don't forget to divide by coefficient of x. Plus, for cos 8x, the integration is sine 8x, divide by coefficient of x, which is 8. Plus, add constant of integration c. We can simplify this a little bit to make it look better. So this 4 and 4 can get cancelled. Multiply this 1 by 8 now again inside the bracket. So you get 1 by 8, or 3 by 8 actually I should say. So you get 3x by 8 plus sine 4x by 8. Multiply this 1 by 8 in the second term. Plus sine, multiply this 1 by 8 over here. 8x divided by 8 times 8. 64 plus constant of integration c, and that's your final result for the integral. I hope that makes sense. All right, now let's look at integration of sine square x divided by 1 plus cos x. Now we just studied that integration or the formula for 1 plus cos. We know the formula for 1 plus cos 2 theta is 2 cos square theta, right? And the angle becomes half. That 2 theta becomes theta. Okay, that's the formula for 1 plus cos 2 theta, one of the most important formula in class 12th trigonometry, and also in integration. While doing integration, one of the most important formula to remember is 1 plus cos 2 theta, and the other one is 1 minus cos 2 theta is 2 sine square theta. The angle becomes half. Okay, so remember this formula. Uh, for for sine theta, we'll see how to do that. But before that, let's say this is I integration of. Let's first work on denominator. So what in the denominator, you can convert 1 plus cos using this formula. So 1 plus cos 2 theta can be written as 2 cos square, angle becomes half, so that x will become x by 2. Okay, so that 1 plus cos x will become 2 cos square x by 2 using this formula. All right. Now, if we are converting the angle of denominator to x by 2, why not convert the angle of numerator also to x by 2? We just did this similar example sometime before, where we had cos square here instead of sine square. So we can convert that x or sine x into x by 2. How to do that? We already did that in our formula discussion. Let me remind you. We know the formula for sine 2 theta is 2 sine theta into cos theta. That angle becomes half. Okay, that angle is half. So sine 2 theta can be written as 2 sine theta cos theta. So similarly, this sine square theta. So this sine square theta. Remember, this is just like sine x the whole squared. Okay. So this is just like sine 2 theta, which can be written as sine 2 theta is 2 sine and cos. 2 sine cos and the angle becomes half, x by 2, x by 2. Okay, so that sine 2 theta can be written as 2 sine theta cos theta, and that angle becomes half, and there is whole square, don't forget here. Okay, divide by 2 cos square x by 2. Now, if you observe carefully, if you give this square in all the terms because it's multiplication, so you'll get integration of 2 square is 4 sine square x by 2 times cos square x by 2. So this square can be given to 2 sine square or sine x by 2 and cos x by 2. So you get this divide by 2 cos square x by 2 dx. Very simple. Now if you notice, this 2 and 4 will get cancelled and you'll get 2 in the numerator. And this cos square x by 2 and cos square x by 2 will also get cancelled. So after that, basically you are left with integration of 2 sine squared x by 2 dx. Okay. Now that 2 is constant can be taken out of integration. So you get 2 integration of sine squared x by 2 dx. Now, can anybody remember how to integrate sine square x by 2? Since it is power 2, again we have to convert that power 2 into power 1 that we have been doing in this video a lot. So we can again apply, we know the formula for sine square theta is 1 minus cos 2 theta divided by 2. Okay, these formulas are so important that you will use it again and again and again. So I'll recommend you just remember or memorize these formulas so that solving these kind of problems will become a cakewalk for you guys. Okay. Also, just to give you a recap, cos square theta was 1 plus cos 2 theta divided by 2. Okay. So we can apply the formula for sine square theta over here. Just note that the angle is double here. Okay. The angle is double. So what you get here is 2 integration of sine square, this sine square, is 1 minus cos, the angle is double, so that theta will become 2 theta, so that x by 2 will become 2 times x by 2. Note that the angle is becoming double, okay? Divide by 2, okay? That 2 and 2 will get cancelled. Don't forget to write dx here, okay? Now this 2 can be taken out of integration because it's a constant. So you will get this 2 divide by 2 integration of 1 minus cos, this 2 and 2 got cancelled, so you are just left with cos x dx. Also this 2 and 2 will get cancelled, okay? So you are basically left with integration of 1 minus cos x dx. Now split that integration in both the terms, so you will get integration of 1 dx minus integration of cos x dx, which will become integration of 1 is x, integration of cos x is sin x. Coefficient of x is 1 here, so no need to divide by 1. If there was some other coefficient, always remember to divide by coefficient of x. But in this case, it's just 1. So x minus sin x plus add a constant of integration c. That's your final result of integration. I hope this makes sense. It's a very important example again. Please practice well. All the solutions of this video will be available in the description. Please make sure to like this video and subscribe to my channel for more such useful content. Thank you guys.